Hey, what's going on, guys and girls? I don't like this one. Stop. Hey, what's going on, guys and girls? So in this lesson, we're going to talk about the atomic number, the mass number, and isotopes. And I also noticed in the last video, I get a really nice shine, a really good glow on the head here. The big baldness right here. It's a good reflection I noticed. So anyways, just something I noticed in the last video, the very first one I ever made. But regardless of that, let's get to this stuff. So let's first talk about what we're going to do here. In this situation, we are going to figure out the atomic number, the mass number, the protons, the number of electrons, and number of neutrons for each element using the periodic table. Now, one of the important things we have to remember is we are going to assume for right now that every single element is currently neutral. In the last video, we talked about neutral atoms. We'll get back to that review here in a second. So, first, I have iron. I need to figure out what is the atomic number, the mass number, the protons and neutrons, and the electrons. Well, you know from the notes, and we talked about in the last video, that in order to find the atomic number, we look on the periodic table. It is the whole number located for that element. So for iron, which actually if you're trying to find it, the symbol is Fe. It is the atomic number 26. Now, what does that tell us? If the atomic number is 26, then the protons must also be 26. Because remember, the number of protons is the atomic number, and the atomic number is the number of protons. Then I mentioned that every element currently is neutral. And if you recall, neutral atoms have to have the same number of protons as electrons. So if protons are 26, the electrons are 26. A very big misconception, by the way, is that the atomic number tells you the number of protons and it tells you the number of electrons. Okay, that's true when it's neutral atoms, but that's not going to be true later on. The atomic number is always 100% always the number of protons. The electrons can change depending on the situation. But for now, yeah, they are the same. But again, whenever I ask, hey, what does atomic number equal? Always just say protons. Next, we have to figure out the mass number. Now, this can be a little tricky depending on circumstances. Since it says iron, and that's all it says, in order to find the mass number, I need to go to the periodic table. And if I pull up the periodic table, in fact, let's just do that. I didn't even think about that. Might as well. Why not? In fact, let's get on Moodle. Do Moodle. Red. Unders chemistry. Woo. There's a periodic table here somewhere. There it is. Periodic table. There's that 26 I was talking about. There's the atomic number. So here, we're going to use this number here. If you recall from the notes, this is called the average atomic mass. Or sometimes it's called the average mass number. Or sometimes, in short, just the average mass. So the average mass is always a decimal. Usually. Down here, you don't get the decimals. But for the most part, the majority of the elements are decimals. So the average mass is 55.845. Now, if I don't specifically give you a mass number, notice there is no number right here, which is usually called the mass number. Like for here, there is a mass number there. If I don't give you a mass number, you need to take the average mass and round it to the nearest whole number. So 55.8. What does that round to? To the nearest whole number. Well, it rounds to 56. So the mass number is 56. And I'm going to write that there too. Again, a lot of times you can see elements written like this. It'll be the name of the element. Sometimes they do just a symbol, but a lot of times it's usually the name of the element, hyphen, and then a number. This number is the mass number. The mass number. Now, what does the mass number tell us? The mass number is how many protons and slap my hand. It's how many protons and neutrons there are in the nucleus. I'll repeat that. The mass number equals protons plus neutrons. mass number equals proton number. Well, I shouldn't say proton number. Number of protons plus the number of neutrons. So, here's where we kind of have a problem. We know the number of protons. We know the mass number, but we don't know how many neutrons there are. So here's how it's saying. We know that 26 plus something has to equal 56. 26 plus something equals 56. So the mass number is 56. That equals 26 plus however many neutrons there are. So basic algebra, man. How do you get those neutrons by themselves? Easy. Subtract 26 from both sides. So when I subtract 26 from both sides, 56 minus 26, I don't like how that worked. I'm going to write it like this. Oh no, there we go. Minus 26 equals 30. So there are 30 neutrons for this particular atom. There are 30. So a very, 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 very important equation to know is the following. If you want to find neutrons, if you're looking for the number of neutrons, why did I write this? Simply do this. Do mass number minus atomic number. Or if you really wanted to, you could have said mass number, let's do it like that. You could have said mass number minus the number of protons. It doesn't really matter. I didn't make a big minus sign, whatever. But the point is, the mass number minus the protons or mass number minus the atomic number will always give you the number of neutrons. So again, if you don't know neutrons, but you know mass number and you know the atomic number, you can easily find the neutrons. Okay, let's go to the next example. Bromine 85. Okay, now, common mistake, people say, oh, 85 is the atomic number. No, 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 no. This is the mass number. The number that's anytime that's written next to this element like this, written in this notation, this is the mass number. So if I want to, I can actually put the mass number here, 85. To find the atomic number, we need to go to the periodic table. So let's find bromine. There it is. The atomic number is 35. The atomic number is 35. There we go, 35. Now, be careful. Notice I said the mass number is 85. But if you look at the periodic table, that says 79.9. Well, you'd be like, well, shouldn't that be 80 then? Shouldn't the mass number be 80? Okay, you make a good point. But this is very important. I'm going to stare right at you. Whenever I give you a mass number, you must use the one I give you. Again, whenever I give you a mass number, you must use the one I give you. Very good. Now, if I don't give you a mass number, like in iron, then you go to the periodic table and round the average mass. Okay. Now that I have these two pieces of information, the rest is easy. Protons. Well, the atomic number is 35. Protons are 35. I'm going to skip neutrons for now. Electrons. Since the atom's neutral, if I have 35 protons, I got to have 35 electrons. To find the neutrons, mass number minus atomic number. So 85 minus 35 equals 50. So there are 50 neutrons. Let's go to the next one. Another different notation. Zn, which is zinc, and then you have a 65 up here and a 30 down here. This 65 is the mass number. This is the mass number. And I give it to you, so you have to use the one I give you. This 30 is the atomic number, and I can't make that number up. Okay, zinc has to have the atomic number 30, because remember in the first video, protons determine what element you are. So if the atomic number is 30, it's got to have 30 protons, and that's zinc. So for this, the atomic number is 30, the mass number is 65, and the rest are easy. Atomic number is 30, therefore, whoa, there we go. Atomic number is 30, therefore protons are 30. Find neutrons, I'll do 65, mass number, minus the atomic number 30. 65 minus 30 is 35. Since the protons are 30 and it's a neutral atom, then the electrons are also 30. In the final example, I have bromine, but notice I didn't give us a mass number, but I did give us neutrons, and I'll talk about why here in a second. So let's do this. Bromine, we know the atomic number of that is 35. Okay, for the mass number, you're probably going, hey, I'm going to go to the periodic table and just round that number. Be careful. A lot of times, yes, that is what you do. But notice what I've done here. I've already given you the number of neutrons. I've already given you the number of neutrons. And remember, what is mass number? It is how many protons plus neutrons there are. Now, we already know the atomic number is 35. Therefore, we know there are 35 protons. Can we find the mass number? Yes. All we have to do is do 35 plus 44, which, if I'm not mistaken, don't use a calculator, Osborne, should be 79. The mass number is 79, so I'm going to put 79 here. And then the electrons would be 35. Again. The only time you ever take this number here, the average masses, and round them to the nearest whole number is if, one, I don't give you a mass number like I did here or here. Both in these examples, I gave you these mass numbers. Or, in this example, where I gave you the neutrons. If you recall, in the very first example, I didn't give you neutrons, nor did I give you a mass number. If I don't give you a mass number or neutrons, then I gotta go, oh, what's the average mass? Find iron. There you are. What's the average mass? Now round that to the nearest whole number. So, 55.85 or 55.845, that rounds to 56. 56 minus 26, that's 30. And there you go. Now notice, look at these. Bromine and bromine. They have different masses. No, the atomic numbers are the exact same. The protons are the exact same. The electrons are the exact same. But the neutrons are different, which means the mass numbers are different. There's a special name for that. Those are called isotopes. Isotopes. Which I can go to this here now. Isotopes are elements with the same number of protons, which means they got to be the exact same element. Because remember, if you have the same protons, you're the same element. So it's elements with the same number of protons, but different number of neutrons, aka different mass numbers. So for example, carbon 12, carbon 14. Both of them are carbon, but one has a mass number of 12, one has a mass number of 14. Now, they both have 6 protons because they're both carbon. And they both have the atomic number 6, which you can see here, atomic number 6. The bottom number is always the atomic number. Here's another way I wrote it, there. Okay, now, but if you look, the neutrons are different. This one has 6 neutrons, carbon 12 has 6 neutrons. How did I get that? 12 the mass number, 12 the mass number, minus 6 the atomic number. 12 minus 6 is 6. Carbon 14 has 8 neutrons. Again, mass number, which I got here, minus the atomic number. Mass number minus atomic, 14 minus 6 is 8. So these are isotopes. Same element. They have to be the exact same element, which means the protons have to be exactly the same. But their neutrons will be different. So look for elements that have the same bottom numbers, because those are the atomic numbers, but different top numbers. Those are isotopes. And just to show you this visual, begin. I'm going to pick, I don't know, let's just go with, no, I'm tired of carbon. Let's go boron. So notice, it's boron. Here's the atomic number down here. But watch, when I change the neutrons, the only thing that's changing is the mass number, this top number. That's the only thing that's changing. So right now there are 5 protons and there are 6 neutrons, which is why there's 11. 5 plus 6 is 11. If I add 1 more neutron and make 7 neutrons, the mass number will be 12. Now you're probably, some of you are going, why is it changing from red to black? Why is that letter B going from red to black? You don't really need to know that. Basically what this system does is the black B is the most common type of boron, the boron 11. All the other ones, all the other isotopes, way to use that vocabulary word, Mr. Osborne. All the other isotopes are much rarer, which is why it's in red, because they're more rare. I don't think that's really a word, more rare. Something's either rare or not rare, but I digress. But there you go. So neutrons don't change the element, they just create different versions of the element. I like to think of neutrons like either muscle or fat. So you're going to be you. You are you. But you're either going to be a skinny you, which means very little neutrons, very little muscle or fat, or you're going to be a big you. You're still you, but you have lots of muscle or fat. But you're still boron. Okay? I'm still Mr. O, I'm still Mr. Osborne, but I'm either going to be super big or super small. And, you know, whatever. I got to start lifting weights. Or just start running. One of the two. I don't know. So there you go. That is isotopes. Very important. Very important. So there you go. Our quick understanding of atomic number, mass number, and isotopes. So watch the other videos and get a better idea on how to do this.